So the second part of today's lesson is a quick recap on efficiency. This is nothing that you haven't seen before. You would have seen this in the energy unit in year 9, and you'll even have seen this in either year 7 or 8. But it is explicitly mentioned in GCSE, so it's worth taking some time to look at it again. So for any energy transfer, we have to think about the efficiency of that transfer. So have a look at this GIF here of a physics professor carrying out a classic experiment. He releases the pendulum exactly touching his chin. He lets it go, it swings back, and it doesn't get his chin, it doesn't hit him. So why is that? Well, there is a store of gravitational potential energy when he's holding it because it's high up. As he lets it go, that changes into kinetic energy, the kinetic store, which is the movement. Goes up the other side, gets stored in gravitational potential energy as it gets higher again, and then as it reverses, it goes back into kinetic as it moves. But it does not get back to the same height, which means not all of the energy has gone back in to the height. Some of it has been transferred away. Where has the energy gone? Well, it's gone into overcoming the air resistance, so it's gone into pushing the air out of the way. It's also gone into heating the cable slightly because the cable is moving. There's going to be some friction within the cable. So some energy is transferred away that way. So what would we mean by the efficiency of the transfer in this case? Well, it would basically be how high does it end up compared to where it started. So if you pause the video at the final frame of the GIF, you can see what the difference is, and you could estimate how much lower it is compared to where it started, and then that is effectively the efficiency. So before we get into the maths, look at these 4 examples, and I want you to think about what the useful energy transfers are and what the wasted energy transfers are. So pause the video now and think through that question. So it should be fairly easy, a nice recap of year 7 and year 9. In a car accelerating, obviously the useful energy transfer is to the kinetic store, because that's the movement we care about. And the wasted energy transfers, the main one is the heating of the environment through friction. So that could be hitting the air out the way. It could be the friction between the tires and the ground. Of course, there's going to be some wasted energy transferred away as sound waves. There will, of course, be some heating of the engine to the air around it, which isn't technically through friction, but heating to the environment is the main one. What about a motor working to open a door? Well, again, the useful energy transfer is to the kinetic store because the motor ends up moving the door, and the wasted is, again, any heating of the environment, mainly through friction, maybe also through the cables getting hot. Of course, there'll be some sound as well, but heating to the environment is the main one. A TV, useful energy transfer is radiation in the form of light, and mechanical. Mechanical is a sort of fancy way of saying sound waves, because sound is just air moving. And wasted, again, heating of the environment. And finally, a penguin sliding on ice. The useful, again, is kinetic, and the wasted is the heating of the ice due to friction, which is not obvious when it's something cold like ice, but of course there is still some friction, and of course whenever you have friction you always get a bit of heating. If you don't believe me, take your hands, rub them together, and you'll feel how hot they get. So in terms of wasted energy transfers, pretty much 99 times out of 100, if you write down the wasted energy transfer as heating of the environment, you're almost always guaranteed to get the mark. You might sometimes need to write through friction or air resistance or one other tiny detail, but you're almost always going to have heating of the environment is wasted. So what is efficiency? Well, efficiency is just measuring the ratio of useful to wasted. So what is the ratio of what useful to wasted effectively? All right, it's not quite written like that, but it's almost that. So efficiency is useful output energy over total input energy. Okay, so the useful might be the kinetic, and the total is the kinetic plus all the wasted energies. So if we were looking at a car, for example, the total would be the chemical energy stored in the fuel, and the useful is the kinetic, and everything else is the wasted, which is the heating. Now, sometimes you see it in a slightly different form. So we know that if you take energy and you divide it by time, what do you get if you divide energy by time? You get power. So you can divide both useful energy by time to get the useful power. You can also divide the total input energy by time and you get the total power, right? We've done the same thing to the top and bottom of a fraction, so it's exactly the same. You know this from maths, which means you can also write efficiency as useful output power over total input power. These two equations are exactly the same, and you need to be aware that you can either work in terms of energy and power. You might already be thinking, well, how can they make exam questions hard? Because this is, an easy concept. Well, in GCSE, what they'll do, they'll give you one thing as energy and one thing as power, and you'll be expected to convert either both things to energy or both things to power so that you can use one of these two equations. So, a couple of quick facts on the screen now for you to make a note. You can pause the video now and make a note. What's really important is if you ever get a number that is not between 0 and 1, you are wrong, because you can never have an efficiency greater than 1. You can never get more energy out than you put in. Some energy is always dissipated. Dissipated means transferred. It usually also means kind of wasted, because you can't get this energy back. So some of the energy is always wasted. Also, if you want to convert to a percentage, you multiply by 100. You know that from maths, and it's always okay in science. You can, unless it says, you can always give your answer as either a number between 0 and 1 or a percentage. It's up to you. And finally, they might try and trick you. They might not give you the useful energy. They might say the total energy is, 100 joules, 10 joules is wasted, and then expect you to realize that the useful energy is the difference between. It's super easy, but they try and catch you out. So you just have to really be thinking, are they trying to trick me? All right, so let's look at an example. I've stupidly put the answer up on the screen, but you can pause the video now and read through this example. Okay, let's look at one more example. This is a slightly harder question. If you got this, it would be worth maybe 4 or 5 marks. So the total power supplied to a lift's motor is 5,000 watts. In a test, the motor lifts a mass of 6 kilograms, 10 meters up in 20 seconds. Calculate the efficiency of the motor. So firstly, you need to be thinking, what is the equation for efficiency? Well, it's useful energy over total energy, or it's useful power over total power. You then need to be thinking, what information do I have? Well, I have the total power. So maybe I'll use the power equation. I'll use useful power over total power. Do I have the useful power? No, I have the total power. So what is the useful energy, and therefore what is the useful power? Well, it's a motor lifting something up. So the useful energy is gravitational. How do I work out gravitational potential energy? From year 9, you should know it's mass times gravitational field strength times height, mgh. So I can then work out 6 kilograms times by 10 meters times by 10, which is g, little g, the gravitational field strength is 10. So that's useful is 600 joules. What is the total input energy or power? So I've got the total power, so I'm going to convert this to power. So energy is power times time, which is 100,000 joules, because obviously the motor has this power for this much time, so it uses this much energy in total. So now we can split this into our equation. Efficiency is useful output energy over total input energy, and that gives us actually quite a small number, so it's not a very efficient motor at all. I think I said throughout this I was going to use the power equation. Actually, I haven't. I've used the energy equation. You could use the power equation. You could do this energy divided by the time and keep power as power. They'd give you exactly the same answer. So now that is the end of the lesson. You can complete the final questions on efficiency and, of course, read through the document, which has all this information from both videos in written format for your own notes.